our final topic here, okay, I know this set of lectures is a little bit long, but our final topic here um, is slant asymptotes and end behavior, okay? And this is exploring what happens when our numerator has higher degree, okay? So let's give you one example, okay? This is going to be a rather abstract example, but I think it will show us what's going on. Let's say r of x is some polynomial p of x over some polynomial q of x, okay? Where the degree of p is one more than the degree of q, right? Well, what happens when we actually do this division, right? When we do this division, what are we going to get? Well, we're going to get that r of x is ax plus b, right? Plus whatever my remainder is divided by q of x, okay? And notice this, right? The degree of r, by definition, is less than the degree of q, right? And we need to have that a does not equal 0. So because this is true, because my degree of the remainder has to be less than this guy, well then this guy goes to 0 as x goes to plus or minus infinity, which means that my function is actually going to approach a line. So let's do an example of this, okay? So let's say r of x is x squared minus 4x minus 5 over x minus 3, okay? So first we want to factor this guy. Looks like the top is going to factor into x minus 5 and x plus 1. And our denominator is going to say x minus 3. Next, taking a look, our x-intercepts. Well, those look like to me they're going to be x equals 5 and negative 1, as that's where our numerator is equal to 0. My y-intercept looks like it's going to be negative 3 over negative 5, or 5/3, okay? And what about my vertical asymptote? Okay. Well, my vertical asymptote is going to be x equals 3, okay? And let's think about what happens, okay? As x goes to 3 from the right, what's going to happen? Well, we're going to have a positive here, a negative here, and a negative here. So that means that y is going to go to positive infinity. And as x goes to 3 from the right, we can see we have that same positive, negative, positive. So we're going to get y going to negative infinity, okay? So now part 4, where we examine our horizontal asymptote, but we don't have one, right? We don't have one. It doesn't exist. But we do have a slant asymptote, right? Um, these slant asymptotes are what these guys are called, right? I guess I should have said that this is a slant asymptote. So taking a look at this, okay, let's divide this through, right? So we're dividing by x minus 3, and then our coefficients are 1, negative 4, and negative 5. And during the synthetic division, we have 1, 3, -1, -3, -8. Okay, so that means that r of x is equal to x minus 1 minus 8 over x minus 3. Okay, and so what this means is that this is my slant asymptote. Okay, and we can use that to graph it. I'm going to give myself a bit more room here by moving this guy up there. And this is what's going to happen. Okay, throw down our axes. Okay, and we'll put that there. We have a vertical asymptote at x equals 3, so we'll count out 1, 2, 3. Our x-intercept is here and here. And our slant asymptote looks like this. Okay, so we need to sort of follow along with this guy. We also need our y-intercept of 5/3, which is going to be just below 2. Okay, and now we know that as x gets, arbitrarily large, we're going to approach this line. So we're going to end up going like that and like that. We know that as we go to 3 from the left, we're going to go to positive infinity. As we go from 3 to the right, we're going to go to negative infinity like that. Okay, and now we connect all of this as best we can. These guys are not always the smoothest to draw, but we do what we can. It's going to look something like that. Sure, right? If you were to zoom out, right, and let your axes get really, really far apart, right? What you would see is you'd see your vertical asymptote here. You'd see your horizontal asymptote, say here, right? And if you zoomed out far enough to get this level of detail, you'd see that our graph does this. It sticks to that line, and then as we approach this vertical asymptote, it does that. And then the same thing happens over here for like that. Our box here is just a little bit too zoomed in to really get the full picture, right? We're looking at, that box right there, which is a little bit confusing. This is sort of the large scale behavior of these functions. One more of these, okay? Let's say we want to graph r of x is x cubed minus x squared, or minus 2x squared plus 3 over x minus 2, okay? And we want to factor this guy. Using our tools from last week, you could find that this top factors to x plus 1 times x squared minus 3x plus 3 over x minus 2. Okay, this is one of our irreducible quadratics, so it's not going to give us any zeros and it's not going to factor any further. As such, here we have our x-intercept of x equals -1, and our y-intercept comes from what we've been doing before, 0, 0, 0, -3/2. Okay, perfect. What's my vertical asymptote? Well, I only have one. Right? We have a vertical asymptote at x equals +2. Okay, And as x goes to 2 from the left, I'm just going to tell you on this one so you don't need to work out the signs for yourself. We have y goes to negative infinity, and as x goes to 2 from the right, we have y goes to positive infinity. Okay? So what's happening now? Okay? What about our horizontal asymptote? Well, we know we don't have any, okay? But we can still look to see if there's a slant asymptote of any kind. So we're dividing x minus 2 into my coefficients of 1, negative 2, 0, and 3. Okay? It looks like we have 1, 2, 0, 0, 0, 0, and 3. So that means that r of x can be written as x squared plus 3 over x minus 2, right? And as we go to infinity, this guy goes to 0, which means that my end behavior approaches x squared, funnily enough. So let's draw a graph of this. Again, these are going to be mostly sketches for these rational functions, okay? So let's put our asymptotes down, right? We're going to have 1 at x equals 2. And our end behavior asymptote, again, weirdly enough, is the graph y equals x squared, where I'm going to squish things pretty heavily vertically. I'm going to go up like this guy. And sure, we'll call that our parabola. Our x-intercepts, right? We have one x-intercept at negative 1, and we have a y-intercept at, say, negative 3/2. Put that guy right there. We know that as we go to 2 from the left, we're going to negative infinity. As we go to 2 from the right, we're going to positive infinity. And so we'll say my graph is going to look something like this. It's going to follow my end behavior asymptote, but then as it gets closer, it might stray a little bit. We know it needs to pass through this point and this point and go down. Then here it's going to do something like that. Okay, and this is our graph of r of x.